Hi grade 8s, welcome back to another one of our video lessons. Today we're going to continue with geometry of quadrilaterals and triangles. So we're going to look at problems that involve triangles and quadrilaterals. So we're mixing the two concepts together and we're going to solve problems involving the unknowns, x's and y's and angles and so on. Alright guys, I'm on page 126. I want you to follow me through the worked example and then we're going to look at exercise 11.7. Right, so we have a worked example. We have ABED is a quadrilateral with AD parallel to BE. C is a point on BE such that AB is parallel to DC. Okay guys, so let me quickly draw this thing. I'm going to pause the video. Okay guys, magic. There it is. Okay, so this is the drawing that we have on the worked example on page 126. So I'm going to read through the information again. You guys follow me where the information is. So ABED is a quadrilateral with AD parallel to BE. So AD parallel to BE. C is a point on BE. So there's your C on BE. Such that AB is parallel to DC. AB is parallel to DC. Alright, so before we even continue, they called ABCD a quadrilateral, meaning that it's just a shape with four sides. But they also told us that opposite sides are parallel, which means that this is a quadrilateral. I mean, not a quadrilateral, a parallelogram. Okay? And we know things about a parallelogram, like opposite angles are equal and opposite sides are also equal. Okay, so we can use that in our analysis of this question. Right, let's continue. AB is 6 centimeters, there it is. Well, that makes DC also 6 centimeters. BC is twice AB. Okay, so BC is twice AB. Alright, so if that is the case, if our AB is 6 centimeters, then BC is twice that, so BC is going to be 12 centimeters. Okay? Right? Angle B equals 2x minus 30, we have that. Angle D equals x plus 20, we have that. Angle A is y, and angle E is z. So that's that and that. Right, so using this information, answer these questions. Number one, classify quadrilaterals ABED and ABCD. Give reasons for your answer. Okay, we need to, given the information, we need to classify these quadrilaterals. So the first one is ABCD and the next one is ABED. Okay, well, let's try to figure this out. So the first one, ABCD, is a parallelogram. How do we know? Well, opposite sides are parallel. That's enough to conclude that it is a parallelogram. So we need to state that. So we're going to say that AD is parallel to BC. Okay. What is the reason for that? Why are we saying that? Okay, we're saying that because this information was given to us in the question. They told us that these two lines were parallel. So when that happens, your reason is given. Okay. So it was given to us. Okay, there it is. Cool. Then AB is parallel to DC. Okay, why are we saying that? Same reason. It was given to us in the question. They told us that it was so. Okay, so those two are given. Now we can say, therefore, ABCD is a parallelogram. Okay, parallelogram. Right, so that's enough to prove that it is that, because we've matched up one of the things that we had before, one of the reasons to conclude that this is a parallelogram, and that is opposite sides are parallel, which is what we have. All right, cool. Well, let's now look at ABED. Okay, well, this looks very close to a trapezium, right? Because we have one pair of opposite sides parallel. Okay, we don't really know anything about, well, we know that this is 6 centimeters, which makes DC 6 centimeters. Okay, But can we work out the length of DE? Well, let's think about it. Maybe we can. Well, we can try, because you see, the distinction that I'm trying to make here is that this is definitely a trapezium. But is it an isosceles trapezium? That is what I want to know, because there is a distinction between the two. So to find out if this is an isosceles triangle, we need to find out what these angles are. Okay, because then we'll know if these two sides are the same. If these two sides are the same, that means we have an isosceles trapezium. Okay, so what we need is this angle over here. If we find this angle here, we can find Z. Okay, how do we find this angle? Well, we have corresponding sides here. Okay, so this angle is the same as that angle, which is 2x plus, or rather 2x minus 30. Okay. Right, let's see if we can find what x is. Okay, so I'm going to take this off. Right, what do we know about a parallelogram? Well, opposite angles are the same. Okay, so we know that this 2x minus 30 has to be the same as this x plus 20. Okay, well, let's write that. So 2x minus 30 equals to x plus 20. Why are we saying that? We are saying that because A, B, C, D is a parm. Okay, a parm is an abbreviation for parallelogram. Okay, so you can call it a parm. Okay, ABCD is a parm or parallelogram. Okay, that's enough. So now let's solve for x. This x is going to come to the left and become a negative. This 30 is going to go to the right and become positive. So we have 2x minus x, which will be, so 2x minus x equals 20 plus 30. Okay, so 2x minus x is x equals 220 plus 30 is 50 degrees. Right, so now we know x is 50 degrees. So let's find out what this actual angle is. Well, 2x minus 30. 2x is 100, minus 30 is an angle of 70 degrees. If this is 70, then this is also 70 over here. Okay. How do we know that? We can say that, well, angle DCE equals to 70 degrees. Why? Well, what did we use here? We got the F forming here. So that and that is corresponding angles. Corresponding angles, okay. Which lines are parallel? AD parallel to BE. Okay. Right, so if this is 70, that is 40, what angle is Z? Well, 70 plus 40 is 110, and everything needs to be 180. So Z has to be a 70-degree angle over there. Okay. If now we have both of these the same, that means that this line equals to that line, which is also making it a 6 centimeter line. Okay. Right, so let's quickly state that angle, that Z equals to 70. So we can say Z equals to 70 degrees. Why are we saying that? Well, we have an isosceles triangle. No, not an isosceles triangle. We used angles of a triangle. Okay, so we can say sum angles of triangle. Okay. Z is that. Right, so now we can conclude that ABED is a isosceles trapezium. Okay, I'll write it at the top here. So let's now prove that it is an isosceles trapezium. So the first thing we need is a pair of parallel lines. So AD is parallel to BE. Why are we saying that? Well, it was given to us. Okay. Then we're going to say that AB equals to DE. Why are we saying that? Well, we've proved it by using isosceles triangle. Okay, so we can say isos triangle DCE. Okay, isosceles triangle DCE, that's why we have those two sides are equal, because both the angles are 70 degrees. Great, therefore ABED is an isosceles trapezium. Okay. ABED is an isosceles trapezium, and we've proved that. Okay, guys, so this is how we solve geometry problems. Everything that you tell me, that you figure out a piece, it needs to be accompanied by a corresponding reason. Okay, meaning that what are the reasons that we are using? Sorry guys, I don't think you saw the bottom. So all I did was we proved that DCE is 70 degrees, corresponding angles, AD parallel to BE, and we concluded that Z was 70 degrees. Okay. All right, so I'll try not to write below that, or actually maybe move the camera back a bit. All right, guys, so we've proved that. That was quite a complicated proof. So in the answers, they just said, classify quadrilaterals, give reasons for your answers. So they stopped at classifying it as a trapezium. We went a whole lot further and we said that yes, it is a trapezium, but it's also an isosceles trapezium, okay? So a lot of these calculations that we did is probably the calculations they want us to do in the later questions. But I feel like this is properly answering this question, classifying it correctly. All right, number 2, determine the lengths of AD and BC. Okay, so AD and BC. Well, we already know that BC is 12 centimeters because they said it's twice AB. And we know that AD is the same as BC because it is a parallelogram. And that's your reason for saying that, because all you have to tell me is that this shape is a parallelogram, which means that it has all the properties that it has. And you're using that fact. Okay, so you don't need to have a long, extensive proof telling me why AD is the same as BC. Simply, you just say ABCD is a parallelogram, therefore AD equals to BC. All right. Okay, number 3, calculate the value of X, Y, and Z. Okay, we already have Z, we already have X. We need to calculate the value of Y. Okay, well, that is pretty easy to do because we know that these are parallel lines. So this is going to be a co-interior angle forming over there, right? Well, this plus this needs to equal to 180 degrees. Okay, so Y plus A, or rather Y plus 70 degrees equals to 180 degrees. Reason, what is the reason? Co-interior angles. Which lines are parallel? AD parallel to BC. Okay. Therefore, Y equals, take that to the other side, 180 minus 70 is going to be 110 degrees. Okay, so that is the value of Y, 110 degrees over there. Right, we've done that. Number 4, what type of triangle is DCE? Okay, we already proved it that DCE is an isosceles triangle. Okay, and we have number 5, can you improve your classification of quadrilateral ABED? Well, yes, because we've done all the work already initially. The improved classification is that this is an isosceles trapezium, okay, which means that the end sides are the same and one pair of sides is parallel. Okay, guys, so all the reasons, all the workings are in your textbook on page 126. Now, you might be thinking that this is very complicated and I did all of these calculations and you have no idea what's going on. Guys, this is what geometry is about. That's how we're going to be solving it. So what you need to do is you need to slowly work through each one of these statements and questions, and and make sure you understand what the logic behind this is. Okay, guys. So what I want you to do for homework is do exercise 11.7. So that's looking at different quadrilaterals and finding out the unknowns, pretty much using the same stuff as we did on the board. So it's a very long exercise. Okay, guys, so that's the end of our geometry section, I think. Let me just check. No, I'm lying. There's still geometry of straight lines coming up after this exercise. All right, guys, so what I want you to do then, not do the whole exercise. I'll help you a bit with the harder questions. So I want you to do questions 1, 2, 3, and 4. Okay, 1, 2, 3, and 4 of exercise 11.7. Okay, guys. And then I'll continue with the next question, with the next few questions in the next lesson. I'll look at maybe 1 or 2 difficult ones that I think are a little bit challenging. And we'll move on to our next section, which is geometry of straight lines. Okay, cool guys. I hope you enjoyed the lesson and I will see you next time.